Hello, everybody. We are back. Yay, team. No? Okay. So a few people came to me after class last time asking about the exam. Can people hear me in the back? Is that a thing? Or not, or not. Always a possibility. We could just skip the whole thing. So people have been asking about the exam. And as you know, it's not next week, but the week after, on the Thursday evening. There will not be class on Friday because no one's in the mood to hear anything right after the exam and right before break. It's just not on, right? So anyway, we're spending the hour doing our exam, so we'll drop that class. The exam is going to be multiple choice. It is going to cover everything up till Wednesday's class, this coming Wednesday. So you'll have a week of stuff that's not going to be on the exam. However, you will not be asked to do the math for this model. You will be asked to do the math for this model on the final exam, but math is the kind of thing that you cannot do until you practice it, right? Until you try it yourself, there's no way to do it. And for this round of tutorials, we weren't far enough into it to be able to cover that kind of thing. And so we will not be asking you on the midterm to solve the math for the model. You will be on the final, but not for the midterm. But this model is covered, so it's going to be questions about interpreting the results, interpreting the equations. Why do we set things up the way we set them up? Why do the variables mean what they mean? How do we interpret the answers? So I might, for example, give you an equation and ask a question about that equation, an equation that you've seen, right? An equation that's seen, why is it that way? And like 4 answers about why it might be that way. You have to pick the right one, right? Or I could give you, here's the model, here's the solution, here's some interpretations of that solution, which one is right? Okay, so I would give you the model, I would give you the solution, I wouldn't ask you to find the solution, but you would be expected to understand what that solution meant and why it might be the way it is. Okay, so that's the kind of questions I could ask about this. And of course I can ask about the earlier stuff with the Phillips curve as well. Right. Okay. Questions about the exam? I know people are full of questions about the exam, but it's yeah. Yeah.
How many questions?
15 to 20 questions, somewhere in there. I always think more, and then the externs tell us we can't have that many because people don't have time, so it'll be 15 to 20, and also I run out of ideas for questions to ask is also a thing, but yeah, it'll be in that neighborhood. So you'll have plenty of time. Time will not be an issue on the exam. In fact, I'll let you stay as long as you want, just like last year we did. It was the same thing. Yes? I will look and see what I have. Okay. There won't be anything in the same format, but I will give you some material that you see what kind of questions I ask in different formats, right? Yeah, that's fair enough. I've never taught this class in this format, so it's new. This is the first time teaching the class, so I don't have it exactly this way, but I do have some material on this, some past exam questions and such. Which, yeah. I will also be using as homeworks for when we get to the homeworks on this stuff, but yes. Oh yeah, answer, yeah, I'll get you some stuff. I'm not sure quite what I have to look, see what I've got. Other questions? Yeah.
What time is it?
It's at 7, I believe. It's on Brightspace. It's announced there. So what's on Brightspace is the definitive. Me remembering 7, I believe it's 7. And importantly, it is in BlackRock, right? In the BlackRock Exam Center, which means you have to schlep all the way over there, which takes some time, and it's unpleasant for you. It's unpleasant for me. It's unpleasant for everybody, but that's where it's at. Unless you live in BlackRock, maybe it's grand for you. I don't know. I don't know where you live in your life. Yeah. Okay, so we were talking about the Fisher-Gray model as usual, and we've complicated it up a little bit. Right? We have this new version of the model, which is 6 prime yt minus y bar. Can you read this? Is this a thing? No. Let's zoom you so you can. There we go. Also, in news, it looks like next week we'll have the computer fixed, and that will be great for me, great for you. Everyone will be joyous about this because we've got no recording of this at the moment. There's no way to record it, so again, it's going to be just the slides scanned for the people at home. But you will have the slides scanned. We give it page numbers because of that. And that's equal to theta over 2 pt minus pt given t minus 1 plus theta over 2 pt minus pt given t minus 2. Right, we have these 2-period contracts. Contracts last for 2 years. Some people are renegotiating their contracts in time t minus 1. Some people renegotiated their contracts at time t minus 2. So the people that were way back in t minus 2, they had to predict 2 periods ahead to set their wages. But the people who negotiated their pay contracts just 1 period ago only had to predict 1 period ahead. Right? And that's why they're divided by 2, because half the people are in one group, half the people are in the other group. And we've got our same 7 that we had before, which is mt minus pt is equal to yt minus y bar minus vt, which is, of course, just our rewritten quantity theory of money, quantity identity of money, actually. And we've changed the shock. So we changed 6, and we've changed the shocks. And our shocks are now vt is equal to rho vt minus 1 plus epsilon t, where rho is somewhere between 1 and 0. Epsilon is IID, mean 0. Right. So this is a way to have a persistence in the economy itself. Okay? So we have more complicated shocks, shocks hang around, and we've got more complicated contracts. And we were talking about what those shocks looked like last time. And I gave you a little graph, right? I said we had, here's time, and here's VT. And we said that E1 was equal to 1. All other epsilon equals 0. Right, so we get our graph looks like that, decaying down with a jump in period 1. And then goes down. Of course, this is not something that's likely to happen in reality, right? Because the shocks are idiosyncratic. Sometimes they're going to be positive, sometimes they're going to be negative. I just draw that to point out that if we do have a shock, it is going to take a while to die out. In fact, it will be a little bit of it will be around forever. Right? Another way we can tell the same thing is we can say, well, VT is equal to rho VT minus 1 plus epsilon t, right? That's this. But the same thing was true 1 period earlier. So we had VT minus 1 was equal to rho VT minus 2 plus epsilon t minus 1. So I can plug this in here, and I get VT is equal to rho times rho VT minus 2 plus epsilon t minus 1 plus epsilon t, just substituting in that second equation into the first, right? Which means VT is equal to rho squared VT minus 2 plus rho epsilon t minus 1 plus epsilon t. And I actually prefer to write it the other way with the most recent things first. So let me do that. VT is equal to epsilon t plus rho ET minus 1 plus rho squared VT minus 2. But of course, I can do this 1 period earlier. And that's VT minus 2 is equal to rho VT minus 3 plus epsilon t minus 2. Right? It's a little bit left over from the period before, and then the current shock. Yeah? That would be so helpful, would it not? Yes, thank you. Can we zoom out a little bit as well? No, that's as far as they go. Yeah, sorry. I'm going to turn these on the side. Maybe on the side, less likely to. Okay. Yeah. So much better if you can see it. Yeah. Okay, so we can do that. We can substitute that in. And substituting it in, sort of skipping a step, Vt is equal to epsilon t plus rho epsilon t minus 1 plus rho squared epsilon t minus 2 plus rho cubed Vt minus 3. Just substituting this in here. And hopefully you can see the pattern, right? It's going to be a sum of all the shocks. It's going to be the velocity way back when, times rho to however many periods out we went, plus the sum of all these shocks weighted by how far back they are. So Vt is equal to the sum from I equal 0 to k, rho to the I, E t minus I, plus rho to the k plus 1, Vt minus k minus 1. Right, it's going to be just the sum of all these things. So here we've got the first one, k I equals 0, the shock at time t, times 1. Then I is equal to 1. We get rho to the first power, Et minus 1. Then I is equal to 2. Rho to the second power, Et minus 2. And so on and so on and so on. Going all the way back to the ancient Romans. And we got the shocks that hit Julius Caesar way back when. A little bit of them are still around. But of course, they're multiplied by rho times, 2,000 years. And so rho, which is a fraction to the power 2,000, is really, really small because these shocks decay out. Right? But the little bit is always going to be around. This has lost the plot. Okay. So that's how the shocks work. Okay. People with me on the shocks? Okay. It's a nice, clean, and common way to bring persistence in, but still have these IID shocks that we can't predict, that have mean 0, that are easy to work with. This is called an autoregressive process. Or an AR process. You'll see it in econometrics, particularly macroeconometrics. It shows up all the time in various forms, where you have these shocks that die out over time. The shock hits, it's always a little bit of it going to be around, but it's going to slowly die out. Right? And there's all kinds of things like clever techniques to estimate what this rho might be and all that kind of stuff. Okay? As theorists, we don't need to worry about that, but it's a thing. Okay. Turning this sideways in hopes that we can get the whole page on there. And yes, so much better. So much better. Okay, page 2. And of course, we add on the policy rule, which is mt is equal to minus gamma Et minus 1. So we're going to be looking for monetary policy rules that follow the behavior of something times the shock last period. So they're going to be reacting to last period's shock. And that's presumably something that's possible to do. Right? Reacting to instantaneously to shock seems unreasonable. But in this model, we got people with 2-period contracts. The central bank doesn't know everything. It knows more than people that set their contracts 2 periods ago, but not more than people that set their contract 1 period ago, right? because people that set their contracts one period ago knew epsilon t minus 1, which is the same thing that the central bank is reacting to. Okay? But the people that were at t minus 2, 2 periods ago that were deciding on their contracts, they didn't know epsilon t minus 1. So the central bank will know more about when it's setting its monetary policy more than they did when they set their wages. Okay? Okay, so how do we solve this? Well, we're looking for a rational expectations equilibrium. So the important thing, the crucial thing to solve for is this thing, right? We don't know what these price prediction errors are, that one and this one. And so we need to find them. We need to know, what do people expect the price level to be? And we're looking for their expectations to be consistent with the model. And so the way we do that is we try to find out, what does the model say about prices? How does the model say that prices are determined? So what we want to do is we want to put these things together to look at the process for prices. It's not that we're particularly interested in prices, but we are interested in price prediction errors because that's going to affect output. Right, so we need to find out what these price prediction errors are likely to be. And so what we're going to do is we're going to take 6 and we're going to plug it in to 7 to get rid of the y, and that'll get everything. We have fundamentally 2 things we don't know. We fundamentally don't know y, and we fundamentally don't know p. And we're interested at this stage in how p is determined, so we take the 2 equations together and we substitute out and we get rid of y. Okay? And then we get one equation just in p. So that gives us, if I rewrite it a little bit, well, 7 becomes, 7 I can rewrite as pt is equal to, mt minus yt minus y bar plus vt. That's just 7 written another way, right? It's just solving it for pt. But of course, now I have to substitute in 6. And so we get pt is equal to mt. I can substitute in what this is as well from here. So that's minus gamma et minus 1 minus whatever y is, and y is theta over 2 times pt minus pt given t minus 1 plus theta over 2 pt minus pt given t minus 2, and then plus velocity at time t. Okay. Now, that's kind of like what we had before. It's slightly different in that we got this pt minus 2 silliness going on, right? That's new. And we have to be careful because velocity is new as well, right? This is something that we didn't have before. Before we just substituted in this epsilon because that was the shock. Now we got to substitute in what velocity is. And of course, velocity from before, vt is equal to rho vt minus 1 plus epsilon t, right? So I could substitute in that, but what I'm going to be doing is I'm going to be finding this price process, right? Well, I found it. That's a price process. And we're going to be wondering what kind of price prediction errors that we've got. And so I don't want to substitute in velocity this way. I can do, it's fine. There's nothing wrong with substituting it in this way. But what I really want to get it down to is I want to get it down to stuff that people knew at time t minus 2, because that's when they took their expectations, right? At time t minus 2, they had to figure out what their wages were going to be. And so they were making a prediction about what the world was going to look like all the way now, right? And so there's going to be stuff that they knew then, and then there's going to be stuff that showed up after they set their wages, right? And so I want to write it in terms of, here's the stuff that people at time t minus 2 knew. Here's the stuff that people at time t minus 1 knew. And here's the stuff that nobody knew, right? And we want to get it into those categories. And in particular, I want to write this in such a way that there's I can divide it into those two things, things that people knew at time t minus 2 and things that they didn't know yet. And clearly, they didn't know this, but they kind of knew part of that, right? They knew the part that was left over from the Romans. Whatever that shock was left over from the Roman days, they knew it was really small, but they know it, right? So we need to divide this up. And so what I'm going to do is I'm going to substitute in one more. Vt is equal to Et plus rho Et minus 1 plus rho squared Vt minus 2. Substituting in for Vt minus 1, substituting in Vt minus 1 is equal to rho Vt minus 2 plus epsilon t minus 1. Right, substitute that in, and we get this. Okay? And the nice thing about writing it this way, we haven't added anything to anything, but we're just writing it in a particular way, is at t minus 2, people knew this, but they didn't know any of this. Right? Because they said with all the information at time t minus 2, they could use that. But they didn't know what the shock was going to be in t minus 1, and they didn't know what the shock was going to be in time t. Likewise, guys in time t minus 1, they knew this. They also knew that, but they didn't know this. Right? And so for each of those guys, we can say what they knew and what they didn't yet know. Right? And I could take it further. I could write it in terms of Vt minus 3 if I wanted to. It would be perfectly fine. I just make it work for myself. Right? Because the important thing is, what did people know and when did they know it? And most importantly, did they know it when they were setting their wages? Right? Because if they knew it when they were setting their wages, that's one thing. If it showed up later, that's something else. And when we wrote it this way, part of this was known, part of that was not known. We couldn't disentangle them. We needed to write it out so that we have everything. But if you want to take it out to 3 or 4 or 27 or 2,000, and you have lots of paper, go for it. It won't hurt anything, but it won't be helpful either. Right? Stuff that people knew once they were setting their wages, stuff that they didn't know. So I can substitute that in. The whole thing becomes Pt equals minus gamma epsilon t minus 1 minus theta over 2 Pt minus Pt minus 1 minus theta over 2 Pt minus Pt given t minus 2 plus epsilon t plus rho epsilon t minus 1 plus rho squared Vt minus 2. Okay. We could, if we wanted to, combine these guys because they're both multiplied by epsilon t minus 1. And yeah, I won't do that because it is kind of obvious. It becomes rho minus gamma. But later on, I'll just use it that way. Right? Okay. I know it's going to cause me trouble if I don't. So let me write it this way. Pt is equal to epsilon t from there plus rho minus gamma epsilon t minus 1 from there and there plus rho squared Vt minus 2 minus theta over 2 Pt minus Pt given t minus 1 minus theta over 2 Pt minus Pt given t minus 2. And this we're going to call star. That's our new star. That's the actual price process. That's how prices are determined in this world. If this is how the world works, that's how prices are determined. That's where they come from. Right. Okay. So now that we have our price process, our way to solve this is to say, well, this price process is fine and dandy. It's all lovely and good, except we got these stupid expectations in there that we don't know what the heck to do with those expectations. And the way we're going to solve this to deal with those expectations is say, well, they have to be expectations that are consistent with this, because this is how prices work. We're assuming we have rational expectations, so people should be forming their expectations based on how the world they live in works, and this is the world they live in, right? It's a dumb world, but that's where they live, Fisher-Grayland. That's where they reside. And that's how their world works, and so they have to take all that into account when they're deciding on what to expect prices to be, okay? Now, we could solve it, but now it becomes like a nightmarish hellscape of algebra to try to solve it. It's doable. Like, you could do it. I could spend a class and a half and do it. You'd all be lost, and you'd have to sort yourself out later. But it's much easier if we use guess and verify, right? So now that we've complicated the model, we're getting into the stage where without more mathematical infrastructure, it becomes very hard for us to solve this, right? But we can guess and verify with no troubles. And the next version that we're going to do after this, like, we don't even have the technology to do it yet. We would have to, like, really learn new stuff. God forbid, learn new stuff in class. Like, what horror, ridiculous. But it would be a big tangent, right? We'd spend a month doing it, and why, right? But with guess and verify, we don't have a problem. So I need to make a guess about what this looks like, what this price process looks like. And let me make a guess consistent with my notes, because that would make all my algebra going forward so much easier. Okay, so I'm going to guess. Well, what things should go into my guess? I'm going to guess. I'm trying to find a solution to this thing that doesn't involve expectations. So what I'm going to do is I am going to guess that prices depend on all the stuff that's showing up in this model, right? And I'm going to guess that they show up in a linear way. So that's equal to R1 times ET plus R2 times ET minus 1 plus R3 times VT minus 2. I'm going to call this equation B. Why do I call it B? Because I want it consistent with my notes so I don't get dizzy. There is no A. Like, don't think, where did A go? Like, yeah, years before there was an A. But yeah, no, not touching nothing, right? We saw what happens when I go off piste. It's not good. So we're definitely keeping the same jargon. Equation B. We got star and we got B, right? And we are hoping that my guess for B is consistent with star, because star is the real thing, B is just a guess, right? Well, we need to check, obviously. We need to check, are there R1, R2, and R3 of functions of parameters, are there particular R1, R2, R3 that we could choose that would make these two things consistent with each other? And that's what we're looking for. Maybe there are, maybe there aren't. Who can know? We have to find out. Now, how did I know to guess this? Well, there's two ways to think about it. One way is, look at the equation. These things are showing up there, so probably they should show up here too, right? That seems, at least to me, like reasonable, and it's there, it should be here. That seems okay. Another way to think about it is more fundamental to our actual problem. And that's, if we go back to our actual problem. Is our actual problem on the board? Yeah. We can't get it all on at once. Fine, we'll put our actual problem at the bottom. Yes, actual problem, here we go. Here's our actual problem from the page before, right? We have these expectations. Our problem is these crazy expectations, right? These people setting their wages. And people are setting their wages 1 period ago, and they're setting their wages 2 periods ago. So our guess should depend on everything that people knew 2 periods ago that matters. And again, velocity is the only thing that really matters here. So what they know about that, and then everything that happened since. right? So even if I didn't have this equation, I would still make this same guess, right? Because velocity is what they knew 2 periods ago, and then these things are things that happened since that they didn't know when they were forming their expectations. So even without looking at this, just looking at the original equation, I could have told you that this was the appropriate guess. Because things that they knew 2 periods ago, everything that happened since. Or everything that shows up here should show up here as well. Either one of those, you're grand. Okay. People with me here? I know people get nervous about the guessing part because guessing sounds, how am I supposed to guess whether I get a good grade or not? What the hell is that? But it is not so bad. One hopes. Okay. Page 3, do we have everything on here? Almost on there. Okay, page 3. So now we want to check and see if our guess is consistent with the real thing. Okay? And what we're going to do is we're going to take our guess and we're going to plug it into the real thing and see if the result looks like our guess. Okay. And plugging it into the real thing is, of course, a little harder than you would think because we have these expectation terms. Right? So we need to find the price prediction errors in each of those periods. We need to find this price prediction error. We need to find this price prediction error. So let's do that. Right? Now that we have the guess, if the guess is true, we can now figure out what the expectations are. And if the guess is true, then we'll know what the price prediction errors are. And if the guess is true, we can plug those into our original equation. And if the guess is true, it'll come out looking like the guess. Right? Hopefully, right? That's the idea. So this is fun. Okay, I got missing pages from the notes. We're going rogue, man, we're going rogue. Let's see what happens. How fun will this? Everyone starts to cry. It'll be okay, it's not so bad. Okay, let's do it. Catch my algebra mistakes, please. Please do. Okay, so how do we do this? Well, we're looking for these guys. So let's start with this one, right? Let's find out what is PT given t minus 2, if the guess is correct. Okay, what is it? Well, here's the guess. And so it's going to be PT given t minus 2 information is going to be R1 times ET given t minus 2 information plus R2 times ET minus 1 given t minus 2 information plus R3 times VT minus 2 given t minus 2 information, right? Just taking expectations of both sides. If the guess is correct, reality will look like that. And so my prediction of the left-hand side has to be equal to my prediction of the right-hand side because I'm using all the information in the economy when making my prediction. Right? So everything on the left-hand side taking their expectations, everything on the right-hand side taking their expectations. Right? So what do those look like? Well, we're wondering about this one, PT given t minus 2. That's R1 times 0, right? Because this shock is IID mean 0. So on average, it's 0. Sometimes it's higher, sometimes it's lower, but my best prediction of it is 0. because on average it's 0. Plus R2, again, times 0, because I don't know what the shock is. I'm looking at time t minus 2, but I'm wondering about time t minus 1, and that shock is IID means 0. So all my information at time t minus 2 tells me nothing about what the shock is. That's the IID part. And it has mean 0, and so I put in 0. Yeah?
Excuse me, for the second last one, what is the last one right there? R3V.
Vt minus 2 minus t minus 2.
So it's t minus 2 and then t minus 2.
Yeah, so I'm trying to, what is my best thought about the current situation? Well, I look out the window, like, right? So you're saying, what is your expectation of today's weather? You don't have to expect much. You just look out the door and you see what the weather is. And so this is going to be plus R3 Vt minus 2. Okay. And I put this step, like this is kind of pedantic, right? It's kind of like, why didn't I just put Vt minus 2? Because I want to emphasize to you that you're just taking expectations of the left-hand side and expectations of the right-hand side. But if you already know the thing, then there's nothing really to expecting. It's just the actual thing, right? So if you put €5 in your pocket when you left home, and you're sure that nobody stole your wallet or purse, well, then if people say, what do you expect to find in your purse? You say, I expect to find €5 because I put it there. I know it's there, right? But if it's, what do you expect to find in your purse 2 years from now, you're more uncertain about that, right? But the what's in there now, you know what's in there now. You know now, and you know everything that came before now. You just don't know the future in our supposition, right? Okay, so all of this is just equal to R3 Vt minus 2. Right? If the guess is correct. But we're actually interested in Pt minus Pt given t minus 2. Right? We're interested not in the prediction, but how much of an error do we make on our prediction. So if the guess is correct, Pt is equal to R1 Et plus R2 Et minus 1 plus R3 Vt minus 2 minus Pt given t minus 2, which is R3 Vt minus 2. Right? And this is all if the guess is correct. So our price prediction error is equal, well, that cancels with that. And so the price prediction error is just R1 epsilon t plus R2 epsilon t minus 1 if the guess is correct. Let's call this equation C. Why not? We had B. Call this one C. We're off the map, so I don't know what I called B, C, and D before, but we'll call this one C. This is our price prediction error if the guess is correct. Does this seem reasonable? Well, it doesn't include anything that we knew at time t minus 2, and it includes everything that showed up since then, right? And so that makes sense, because why would I screw up my price prediction? Well, I wouldn't screw it up based on things I already know. I would screw it up based on things that I don't yet know, things that haven't yet come to pass, and therefore I couldn't predict properly. So I couldn't predict, I didn't know what t minus 1 shock is, so yeah, that's going to be a surprise, right? And I don't know what time t shock is, so yeah, that's going to be a surprise as well. But v is not a surprise. If v is high, I'll take that into account. If Vt minus 2 is low, I'll take that into account. But I can't take into account the shocks in t minus 1 because I don't know them yet. And I can't take into account the shocks in time t because, again, I don't know them yet. So I make mistakes because of those two things, things that I didn't know at the time that I was forming my expectations, at the time I was setting my wage. Okay. Okay. see? Yes, we can see. Okay. Now we're going to do the same thing. We have our other thing that we're wondering about, which is, we have it on there? Yeah. Which is pt minus pt given t minus 1. And hopefully at this stage you know the answer, right? You know what this thing is. Right? It's going to be all the stuff you didn't know at time t minus 1. So it's going to be this, right? We knew this, we knew this, but we didn't know that. So we expect this price prediction error just to be R1 epsilon t. But let's find it and see. Like, it's all well and good for Ivan to guess, but we know where that gets me. Like, algebra can go astray. Like, we should do it. So what is pt given t minus 1? If guess is correct. Well, it's equal to the expectation of the right-hand side. The expectation of the left-hand side has to be equal to the expectation of the right-hand side, right? Because what we're saying is, if this is really how the world works, and people know this, when they're forming their expectation at time t minus 1, they're going to expect at time t that this is going to be true, because that's how the world they live in works. That's rational expectations. And so they just say, well, my expectation of p has to be equal to my expectation of all this stuff. So that's R1 epsilon t given t minus 1 information plus R2 epsilon t minus 1 given t minus 1 information plus R3 bt minus 2 given t minus 1 information. Okay, everything we know now. Okay? Well, we don't know this, right? So we just have to put its average in, its mean. So that's going to be R1 times 0, because we don't know it. But we know each of these things. These things are things that are in our information set, things that we know of at the time we're forming our expectations. So they're just going to be themselves, because we know them, right? So R2 et minus 1 plus R3 et minus 2. Like, what is this? This is like saying, this expectation here is saying, what happened yesterday based on today's information? That's like me asking, who do you expect will win World War II? Well, you know who won World War II, despite, Man in the High Castle and all the fan fiction of Nazi stuff that ever was. You know who won World War II. I can ask you who you expect is going to win it. The answer is still not the Nazis, right? So, or maybe in the long game they're doing okay. Anyway, we'll leave that aside. So that one looks weird, but that's all it's saying, right? Given time t minus 1 information, what do I think happened in the past? What do I expect to happen in the past? Well, I know what happened in the past, right? It's just that easy. It becomes that. So this whole thing becomes R2 et minus 1 plus R3 bt minus 2, again, if the guess is correct. Okay. I say this a lot, but it's important to keep track of where we are, right? What we're doing here. We're saying, given our guess, what do people expect? Okay? Our guess, we think it's going to be correct, but we don't know, right? We could be wrong about that. We could have guessed incorrectly, in which case all of this will be rubbish, and the math will tell us that it's rubbish as we go along. Okay, but we're not interested in that. What we want to know is pt minus pt given t minus 1, if guess is correct. Right? And so if the guess is correct, do we still have it up there? Yes, we do, right here. This is our guess, and so pt itself is R1 et plus R2 et minus 1 plus R3 vt minus 2 minus, and if the guess is correct, pt given t minus 1 is this thing, R2 et minus 1 plus R3 vt minus 2. And so we'll call this equation D is pt minus pt given t minus 1 is equal to, let's see, this will cancel with that, And that will cancel with that. Right? So we're just left with R1 ET if the guess is correct. Okay. So now we know what things look like if our guess is correct. Right? We've got equation C and equation D. And if the guess is correct, that's what price prediction errors look like. Now we want to plug all of this into equation star, the real process. Right? We want to say, given our guess, we can now say what the price prediction errors are. So we can plug C and D. Yeah. Which is star. Right, so I'm going to plug them both into star, and we'll see what we get. Okay. We got star up there? Yes, we still do. Okay. So this is page 5. We get PT is equal to ET plus rho minus gamma, ET minus 1, plus rho squared, VT minus 2, minus theta over 2, PT given this price prediction. 1 period ago price prediction error, which is given by D, which is R1 ET. That's equation D going in there. Minus theta over 2 times PT given PT minus PT given T minus 2, the 2 period price prediction error, which from equation C is R1 ET plus R2 ET minus 1. This is equation C. Okay? These are both if guess is correct. Right, so now we've combined our guess with the real process. We've put our guesses into the real process, and now we want to see, does this look like our guess? And R3. If we can find them, if we can find R1, R2, and R3 so that this new equation looks like our original guess, then our guess was fine, like it was one equilibrium. But if we can't, our guess was not right, and we need to start over. We need to make a better guess. Okay. So we just need to put it into that form, and that form was something times ET, something times ET minus 1, plus something times VT minus 2. So let me combine all the R1 terms, all the epsilon terms, all the epsilon T minus 1 terms, and all the VT minus 2 terms. So this is PT. Epsilon T shows up here, here, and here. So this is 1 plus theta epsilon T, right? We have the 1 from here, 1 multiplying epsilon T here. We have, 1 plus R1 theta. 1 plus R1 theta. 1 showing up there. R1 theta over 2 here. R1 theta, okay. 1 minus R1 theta epsilon T, right? Because we got minus R1 theta over 2 here, minus R1 theta over 2 here. So we get R1 times theta there. Correct? Yeah? Algebra checkers? 200 algebra checkers, please check for me. And everyone free rides. It's better to have 2 algebra checkers than 200 algebra checkers, because 200, everyone's just thinking their own thoughts. Okay, and then we've got epsilon T minus 1. So we got these epsilon T minus 1s and these epsilon T minus 1s. So plus rho minus gamma from here minus theta over 2 R1, R2 epsilon t minus 1, and then plus rho squared bt minus 2. Okay, I have to let you go. So we will solve that for R1, R2, and R3 next time. R3 clearly just v squared, rho squared, so that's nice. The other is a little more messy. Have a good weekend.